Hi, welcome back. This is an independent practice video for 1.2 Common Factors and Multiples from Course 1A Singapore Math. I'm sure you watched the content video and you're ready to solve independent practice, so let's begin. Find the common factors of each pair of numbers. So basically, we have to find the common factors. And how do we do that? First, we need to list down the factors for that matter, right? So we can say 18 can be written as 1 times 18. It can also be written as 2 times 9. And we can also say that to be 3 times 6. So it's basically you go on like this and list down all the factors, the possible ways in which that number can be expressed, right? Now, how do you know when to stop? Here after 3, it's 4, 5. It won't go in 18. And then 6. 6 times 3 and we already have 6. It means we can stop here. Likewise, we do for 63. So we say it's 1 times 63, right? And then it ends with 3. It's an odd number, so not divisible by 2. 6 plus 3 is 9, so it's divisible by 3. So it's 3 times 21. You can check here, 63 divided by 3. So that's times 2 and that's 1, right? And it is also 7 times 9. These are the possible ways in which these two numbers can be expressed. Now the next step here is to list it down. So we say that 18, the factors are 1, 2, 3, 6, 9, right? So all these numbers that you have here, you list them down and have comma as the separators. Same thing for 63. 1, 3, 7, 9, 21 and 63. Now from this, we start circling the numbers that are common that you find in both the list. Like 1 is common in both the list. 2 is only in 18, not in 63. Then you have 3. Yes, you have 3 in both the lists. 6, not here. 9, yes, we have it here. And we have it here. 18 is not in the next list, right? So these are the common factors. So we can say that the common factors, right? I'm just going to write CF here, but you will write it common factors. You write the whole sentence. Common factors of 18 and 63 are 1, 3, 9. These are the common factors. And it's done. Simple, right? Let's go for the next one. So the next one is 30 and 50. 30, so we say 1 times 30. It is also 2 times 15, right? It's 3 times 10 and also 5 times 6, right? The next number is 6. 6 is already here, so we know we stop here. 50, we can say 1 times 50. It's also 2 times 25. 3, 4 won't go, 5 times 10, 6, 7, 8, 9 will not go, and then 10, and we already have it here. So we will say that 30, the factors are 1, 2, 3, 5, 6, 10, 15, 30. I like to spread it out so there's enough space and there's no confusion. 50, 1, 2, 5, 10, 25 and 50. Now let's check the common factors. 1 is there. Of course, 1 will always be there, right? Then 2 and 2. 3, we don't have it here. 5 and 5. 6 is not here. 10 and 10. 15 is not here. 30 is not here. So the common factors, you're going to write the whole thing. Common factors of 30 and 50 are 1, 2, 5 and 10. And it's done. Let's go for the next one. 26. We can write this as 1 times 26. We can also say 2 times 13. Do we have anything more going there? No. 3 will not go, 4 will not go, 5, 6, 7, 8, none of them. It's only 13 that will go. And we already have it. So this is basically having enough practice that will help you know when to stop. Okay, as you will keep trying and you will put in a lot of time there. 78 is 1 times 78. That's 2 times 39 as well, right? 78 divided by 2 because it's an even number, so definitely 2 will go, right? So that's times 3, 6, 1, 8. So that's times 9, right? So 39. 39 also tells me it has to go in 3, right? 7 plus 8 is also 15. So let's try 3. So 3. 3 times 26. So let's do it here. 78 divided by 3 times 2 is 6, 1, 8. That's 6, right? 3 times 6 is 18. So that's 26. It does not go in 4, 5 now, 6, yes. So let's do it here. 78 divided by 6. Once it's 6, 1 and 8. So that goes times 3, right? So 6 times 13. So these are the factors. Now let's list them down. 26. We say 1, 2, 13 and 26. 78, 1, 2, 3, 6, 13, 26, 39 and 78. Let's circle the common factors now. 1 and 1, 2 and 2, 13, 13, 26, 26. We write the common factors are 1, 2, 13 and 26. Okay, because 26, do you see here 26, right? So all the factors of 26 will be there in 78 as well. Let's go for the last question of this type. 55 is 1 times 55. Then we can say it's 5 times 11, and that's it. 88 would be 1 times 88. That's 2 times 44. Then you have 11 times 8. Let's list down the factors. 55 is 1, 5, 11, and 55. 88 is 1, 2, 11, 8, 44, and 88. The common ones. 1, 1, 11, 11. Right? Looking at the numbers, you could have easily guessed that 11 is going to be the common factor. So you will write the common factors of 55 and 88 are 1 and 11. And it's done. So these were the 4 questions based on the common factors, where you had to find common factors of each pair of the numbers that were given to us. Now let's move to the next ones. In the next 4 questions, we are going to do greatest common factor. Greatest common factor. So greatest means the largest, the biggest, right? And common, it has to be in both. Okay, and it's a factor. So there are different methods given to you in your book. You're given basically 3 methods. I'm going to use all the 3 methods, but not for each one. I'll employ 2 methods for each question. Okay, so 24 and 36. The first method that I want to show here is 24 and 36. I'm sure the content video has helped you understand these methods. And I'm using the same ones here, right? So we say first prime factor, that's 2. It will go in both, right? Because both are even numbers. So that's 2 times 12 is 24. And 2 times 18 is 36. Right? So what you're writing here, it's your divisor. So 2 was the divisor. So 24 divided by 2 is 12. 36 divided by 2 is 18. Again, we write 2 because both are even numbers. So 12 divided by 2 is 6. 18 divided by 2 is 9. I have to find a divisor that would go in both the numbers. That's a condition. That's an essential condition here. Like 2 would go in 6, but 2 would not go in 9. So I will not use 2 anymore. I'll go for the next prime number that goes in both, okay? And that's 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Now there's nothing common in this, right? So this is where we end this process. And these 3 numbers that you have here, you have to multiply them to get the greatest common factor. So the greatest common factor is going to be 2 times 2 times 3, which is 2 times 2 is 4, 4 times 3 is 12. That's the answer here. Okay, so that's one of the methods. Let's use another method. In this, we do factorization again individually. So 24, that can be written as 2 times 12, right? Then that 2 comes down, that's 2 times 6. That 2 comes down, this 2 also comes down, and 6 can be 2 times 3. These are my factors. So 24 equals to 2 times 2 times 2 times 3. Fine. We do the same process for 36. So 36 is here. That's 2 times 18. That 2 comes down. That's 2 times 9. Again, this 2 is down, this 2 is down, and this one is 3 times 3. All prime factors. So 36 equals to 2 times 2 times 3 times 3. I'm sure you remember this are the last things that we write down. We multiply them, right? And now here we find the common factor. Which are the common factors here? 2, 2, 2, 2. There's 2 here, but we don't have it in 36. So we take this 3 and we take 3. So these are the common factors. So we say 2 times 2 times 3, right? We just multiply the common one. So 2 times 2 is 4, 4 times 3 is 12. So that's the answer, the same answer, okay? So these are the 2 methods that I have used here. You have 3 methods in all. I'm going to do 2 methods per question. But I have tried to have balance of all the methods so that you have enough practice. And you can do this using the third method and check whether you're getting the answer or not. I'll go to the next one. 42 and 98. So I will write 42 equals to 1 times 42, the method that we use to get the common factors, okay? That's 2 times 21 also. It's 3 times 14 also. And it's 7 times 6. And likewise, we have 98. So that's 1 times 98. It is also 2 times 49. And 98 is also 7 times 14. Well, you need to know your times tables very well for this process. So let's list down the factors of each one. So 42 is 1, 2, 3, 7, 6, 14, 21, and 42. 98 is 1, 2, 7, 14, 49, and 98. Now let's circle the common factors. 1, 1, 2, 2, 7, 7, 14, 14. That's it. There are no more common factors. Now, of these common factors, let me just write down that. Common factors are 1, 2, 7, and 14. Which is the highest? We are finding greatest common factor, right? So which one is the greatest? This one. So the answer is 14. So this is another method, the third method, right? So this is one of the ways to solve it. So the greatest common factor for this is 14. Now let me use the next method, 42 and 98. This is a second method I'm trying, okay? That's 2, 21, and that's going to be 49, right? Now 21 and 49, what do they have common? The numbers tells you, if you know your times tables, the numbers will speak to you. And it says it's 7. That's times 3. So 21 divided by 7 is 3. 49 divided by 7 is 7. No more common factors. What do? We have to multiply this. So it's 2 times 7, which is 14. Same answer. Okay. So you have to try doing the same question using the method that I've missed on. Okay. In the previous one, I did not do common factors method. So you will do that here. In this, I'm not doing this tree method that you have here, listing down the factors, right? Expressing numbers in terms of their prime factors. So do that over here. So the one that I'm not using is the one that you're going to do to see if you're getting the right answer. I'm confident that you will. So go for it. We have two more questions for this. 65 and 91. Well, 65 is 5 times 13, prime factors, done. And 91 is 7 times 13, prime numbers, it's done. Okay? So we say 65 equals to 5 times 13 and 91 equals to 7 times 13. What's the common one? 13, 13. So the greatest common factor, write the whole thing, for 65 and 91 is 13. Let's do the next one method. 65 and 91. I'll do this method. It will go faster. The common one is 13. That's 5 and that's 7. 5 and 7 has nothing in common. So this is your GCF, greatest common factor. It was easy, right? Simple numbers. It's just that I knew my times table for 13. It's very important that you learn times tables at least up to 15. And if more, that would be amazing. It's going to make your life easy. Let's go for the last one of this type. 84 and 100. Remember, you have to do the third method that I'm not using. 2 even numbers, right? So 84 divided by 2 is 42. 100 divided by 2 is 50. Both are even numbers, so I'll go with 2 again. 42 divided by 2 is 21. 50 divided by 2 is 25. 21 and 25 have nothing in common, so we stop here. And we say 2 times 2 equals to 4 is the answer, the greatest common factor. So let's go to the next method. And this method, I'm doing this. 84, I express this as 2 times 42, right? 2 comes down. 42 is 2 times 21 again. This 2 is down, this 2 comes down, and 21 is 3 times 7. It ends there, right? Because they all are now prime numbers. 100. 2 times 50. 2 comes down. 50 is 2 times 25. 2 comes down. This 2 comes down. And 25 is 5 times 5. So I write the factors now. So 84 can be written as this, right? 2 times 2 times 3 times 7. And 100 can be written as 2 times 2 times 5 times 5. Let's look for the common factors. 2, 2, 2, 2. That's it. So it's 2 times 2, and that's 4. 2 methods. Third one is on you. So greatest common factor ends over here. So let's move to the next section. It says, find the first 5 common multiples of each pair of numbers. Multiples, okay? So these are going to be like the multiples of 3 are 3, 6, 9, the answers that you have. The multiples of 5 is 5, 10, 15, 20, and likewise. So those are the multiples, okay? So we have 5 and 6. Well, let's list down all the multiples for 5 first. So 5, you know the answer, right? 5 is an easy one. 5, then you have 10, then you have 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and so on. Let's just stop here for a while. Let's go for the next one. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, and so on. Now let's see if we can find some pattern and then understand it and use it further. So common multiples. We see the first common 5, 10, 15, 20, 25. Do we have it here? No. This 30 is here. Okay. 35, 40, 45, 50, 55. We don't have it. Next one is 60. So we need 5. We just have done 2. So you can go on. You can have a long list over here. But now you understand the pattern, what's happening. 30, 60. Does that tell you what will be the next number? Yes, it's the differences of 30, right? Because 5 times 6 is 30, or 6 times 5 is 30. So difference between these two numbers is going to be 30. So we can have the list. 30, 60. What's the next? Plus 30 will do, right? So that's 90 plus 30, 150. Okay, so these are the first 5 common multiples, right? So this is how you do this. So it's very important to know your times tables. Yeah? Okay. Ready for the next one? It's 4 and 7. Easy numbers, right? So let's list down all the multiples of 4. You know 4's times tables. So let's go for it. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60. Let me just stop there and see the next number. If need be, we will add more numbers there. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84. Okay, let me see if I can have some at least 2 common multiples so I can identify the pattern. So 4, 8, 12, 16, 20, 24. We don't have anything here. We have 28 and 28. 32 no, 36 no, 14 no, 44 no, 48 no, 52 no, 56 yes. Okay, so we got 2. So we are good to go. So let's write those 2 first. That's 28 and 56. What's happening? 28 plus 28 is 56, right? So you keep adding 28 to this and you will have the next number. So 56 plus 28 will be how much? 84. You can check here. 56, 28. That's 4, that's 1, 8. Next, plus 28. It's going to be 1, 1, 2. Plus 28. That's 2, 1 carry, that's 1, 11, right? And then plus 28 will be 140. Let's check. 0, 1 carry, 1, 2, 3, 4. Okay? So these are the first 5 common multiples. Easy? Yeah? Good. We have 2 more. Do you want to practice? Do you want to solve them by yourself and come back to check my answer? Go for it. All the best. Next is 9 and 10. While you're solving, I also have to solve, right? Otherwise, I'll be behind you. So 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. 10, 20, 30, 40, 50, 60, 70, 80, 90. I reached 90, yeah. So 90, 90, right? So it's 9 times 10 and this is 10 times 9. So that gives us the pattern. 90 plus 90 is this. If you look at this, it says 90, 180. It's just adding 0 over there. 270, 360, 450, and so on and so forth. But we just need 5. It's that simple. Let's go for the last one from this category. 15 and 25. Let's list the multiples for 15. 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, and so on and so forth. 25. This one is easy. 25, 50, 75, 100, 125, 150, 175, 200, and so on and so forth. 75, 75, 150, 150. So we know the pattern, right? So 75 plus 75 is 150, plus 75 will be 225, plus 75 would be 300, and plus 75 is 375. Now here, in the first three questions, we saw that first, like for example, here we said 9 times 10, 10 times 9, right? 4 times 7, 7 times 4. And here 5 times 6 and 6 times 5 is when you are getting the first common factor. Whereas here, in this case, it's not 15 times 25. Why? Because 15 and 25 have a common factor, which is 5. Okay? So let me explain that. 15 is 3 times 5, and 25 is 5 times 5. So for them, the first occurrence would be 3 times 5. I write the first ones, and now 1 5 is already covered, so I will not write that, and then I'll say 5. So that's 3 times 5 is 15, 15 times 5 is 75. So the first occurrence is at 75. The common factor 5 is taken only once. Understood? Why it's not 15 times 25 as it was in the case for the other three? Because of this, they have a common factor. That condition remains true when they do not have any common factor. They multiply with each other, that's the first occurrence. Here, because they have common factor, this is how it works. The common factor is only taken once. So this is a strategy for you to check your answer, or even to get your first common multiple, and then you go on by adding that number. Now we move to next set of questions where you're finding the least common multiple. In the previous questions, you found first 5 common multiples, right? So you got to find the least one. What was the smallest one of that is what we are doing here. Now to do that, you have 3 methods in your book. I'll be employing 2 of those, and the third I leave it for you to practice as we did in previous questions. So let's start with this 7 and 12. So we do 7 and 1 times 7. That's it, right? 7 cannot be further divided. We do 12 here. So that becomes 2 and 6. Again, this 2 and 3, right? And this 2 comes down as it is. So we say 7 is equal to 1 times 7, right? And 12 is equal to 2 times 2 times 3. So 2 times 2 times 3. Do we have any common factors? No, we don't, right? So we are going to multiply each one of them. So to find LCM, that's least common multiple, we do this 7, then all these factors here times 2 times 2 times 3. So it's basically 12 times 7, right? So the answer is 84. Okay, so this is how you do least common multiple methods. You get the first common multiple by doing this process. Alternatively, you can do this process also. Let me show the next method, 7 and 12. We start dividing. Now, when we were doing greatest common factor, we would take only the one that has common there, right? Otherwise, we stop there. But here we go like this. So we say 2 and 7 over here, and that's 6. Again, 2, 7 over here, and 3. Now we do with 3. That's 7 and that's 1. We go 7 and that's 1 and 1. So basically we multiply this. So that's 2 times 2 times 3 times 7, which is again 84. Okay? So do you understand the difference between the greatest common factor and least common multiple? In the greatest common factor, let me go back here. What were we doing? Here, if you see, we only did when we could have a common factor. Like when we reached 21 and 25 here, there was no possibility to have a common factor. So we stopped doing that. Unlike least common multiple, where, let's go back there. We continued doing, right? Irrespective of whether it's common or not. We did a factor. So it can go in one of them or it can go in both of them. That does not matter. You continue until both of them becomes one. So that's the biggest difference in the process. Let's go for the next one. 5 and 8. So we write 5 here and 8 here, right? This process, this method. So we start with the lowest prime number. That 5 remains as it is and 8 divided by 2 is 4. We go further. 5 as it is. 4 divided by 2 is 2. Further 2, that's 5. 2 divided by 2 is 1. And then 3 is not possible. So we go with 5. And that's 1 and 1. So our answer is going to be this, like you multiply it, right? So let's do the multiplication. So LCM of 5 and 8 is 2 times 2 times 2 times 5. That's 2 times 2 is 4, 4 times 2 is 8, and 8 times 5 is 40. But obvious, right? We discussed when we were doing the first 5 common multiples, when they do not have anything in common, first, you just multiply them, and that's your first common multiple. So that's the first one. So that's, of course, the least one, too. Yeah? Let's do the next method here. 5. So let's start listing the multiples. 5, 10, 15, 20, 25, 30, 35, 40, and so on. 8, 8, 16, 24, 32, 40. I can go further, but I just want the least, the first one, right? So I find that here, 40 and 40. So the least common multiple here is 4040, and it's exactly what's here, right? So that was the third method which we have already used for finding first 5 common multiples. So it's nothing new, right? So try to do this with the third method that I've not used over here, and that's what you're going to do for all the questions, remember? Let's go to the next one. So we have 10 and 14. So let's write 10 and let's write 14. Now we have numbers that have something in common. So let's use this method. We go by 2. 10 divided by 2 is 5. 14 divided by 2 is 7. Now nothing more in common. We go with 5. That's 1 and 7 remains as it is. We say 7, 1 and 1. So this is our LCM, right? So LCM of 10 and 14 is 2 times 5 times 7. So that's 2 times 5 is 10. 10 times 7 is 70. Right? Because they have 2 in common. So that's why 2 got multiplied only once. Remember, we discussed already this when we were finding 5 common multiples. When they have something in common, that gets multiplied only once. And let me use this method here so that this concept gets clearer to you. So we said 10. I've purposely chosen methods to explain you some concepts, okay? So that's 2 times 5. Both are prime numbers. We stop there. 14. 2 times 7. Both are prime numbers. So we stop there. So we say 10 is 2 times 5. And 14 is 2 times 7. Right? So now here you see that this 2 is common. So when we find LCM, we say 2. That common 2 we write only once. Okay? And then what's left from 10? We have 5. And what's left from 14? It's 7. So 10 and 70. So do you see? This 2 here, though we had 2 2's, like each one having 1, we only write it once, okay? So that's how it's not 10 times 14. It's 10 times 7 because this 2 is already taken as a common factor. I hope this concept is clear to you now. Okay? Let's go to the next one. 18 and 24. So we say 18 and 24. Now this will have many common factors. Let's start with 2. 18 divided by 2 is 9. 24 divided by 2 is 12. And again with 2. So 9 we write as it is. 12 divided by 2 is 6. Again we go with 2. 9 as it is. 6 divided by 2 is 3. We start with 3 now. 9 divided by 3 is 3. 3 divided by 3 is 1. And last time we have 3 here. So these are our factors that we need to multiply to get the least common multiple. So LCM is 2 times 2 times 2 times 3 times 3, right? So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, and 24 times 3 is 72. Okay, so because 24 we already did up till here, it was 24, right? 24. Now 24 is what? 6 times 4, and 18 is what? 6 times 3. So 6 is already covered and 3 wasn't, so we have it here. Well, let's do the next method that helps you understand it better. So that's 18. We say 2 times 9. 2 comes down. 9 is 3 times 3. And then we have 24 here. So that's 2 times 12. 2 comes down as it is. 12 is 2 times 6. 2 down, and this 6 is 2 times 3. So these are the factors of 18, and these are for 24. So let's write down. 18 is 2 times 3 times 3. And 24 is 2 times 2 times 2 times 3. Okay, I've rearranged them so that you can see I've not changed the factors. They've been just rearranged, okay, for me to make this circle easy. So that's 2 is common here, right? This is common here, right? So let's do that. Common factors, 2 times 3. Then we do uncommon. We have 3 from here, and then from here we have 2 times 2. So 2 times 3 is 6, 6 times 3 is 18, 18 times 2 is 36, and 36 times 2 is 72. And it's the exact same answer. So do you see that 6, right? 2 times 3 is 6. So both 18 is 3 times 6 and 24 is 4 times 6. So that 6 is taken care of, and that's 3 and that's 4, right? So it's important that you understand this concept so that when you have difficult questions, you are able to solve it. And if you understand this concept, you will remember it for long. And you can check your answers too. Let's go for the next one. Now we have greatest common factor as we did before. The only difference is now we have 3 numbers. Does that mean the process changes? No, it does not mean the process changes, okay? It remains the same process. So let's solve this. 24, 26, 84. Same method. Nothing is different. Let's go with 2. That's 24 divided by 2 is 12. 26 divided by 2 is 13. 84 divided by 2 is 42. Nothing more in common. So we stop here. So the greatest common factor is just 2. 2 is the answer for that. Okay. Let's go for the next method. 24. Let's get the factors. 2 times 12. 2 is as it is. 12 is 2 times 6. That's 2, this 2, and 6 is 2 times 3. So we say 24 is 2 times 2 times 2 times 3. Right? And then we do 26. 26 is what? 2 times 13. That's it. There's nothing more that you can do there. So let's write 26 equals to 2 times 13. Right? And then 84, the last number. That's 2 times 42. Easy to divide, right? And then 42. So this 2 comes down. 42 is 2 times 21. 2 down as it is. And 21 is 3 times 7. So we write 84 equals to 2 times 2 times 3 times 7. Now for the greatest common factor, that factor has to be present in all the numbers. So we have this 2. Now we have 2 and 2 here, but there's no 2 here. We have this 3 and 3, but there's no 3 here. So we cannot take that. So the answer is 2. So 3 numbers, 4 numbers does not matter. The method remains the same. So don't let these 3 numbers scare you, okay? Follow the same process. Let's go for the next one. 30, 48, and 72. So we'll go with the other method now. 30 can be written as 1 times 30. It is also 2 times 15, 3 times 10. It is also 5 times 6. We don't have any more pairs now. Then we have 48. 1 times 48. It's an even number, so it's divisible by 2, right? So 2 times. This is easy to divide, so that's 24. And then 4 plus 8 is 12, so it's divisible by 3. So 3 times 16 times tables. And then 48 is divisible by 4 as well. And then not by 5, by 6, of course. Not by 7 and by 8. So 8 is already here. So we stop that process now. And then 72. It is 1 times 72, 2 times 36, right? Like you divide this, you can use rough papers, you can do the division. And then this is 3 times 24. It's also divisible by 4, so that's 4 times 18. I know that because my times tables, I know very well. By 5, no. By 6, yes. 6 times 12. 7, no. 8, of course. 8 times 9. And we end here. So we know all the factors now. So let's list down all the factors. 30 has factors 1, 2, 3, 5, 6, 10, 15, and 30. 48 has factors 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And last, 72. 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. So let's first do the common factors, then we find the greatest one from that. 1 is common, 2 is common, 3 is common, 4 is not, then 5 is not, then we have 6 here, then 8 no, 9 no, 10 no, 12 no, then next number is 15, it's not, then 16 is not, 18 no, then next number is 24 no, then 24 we have 30, it's not, 36 no. So these are the only common factors. Now we need greatest common factor, so that's 6, right? Because 1, 2, 3, and 6, the greatest one is 6. Let's do the next method here. 30, 48, and 72. Now, first, because all are even numbers, let's start with 2. 30 divided by 2 is 15. 48 divided by 2 is 24. 72 divided by 2 is 36. Okay? And then, now, they all are not even numbers. So 2 is not possible. Let me see whether they're divisible by 3 or not. 15, yes, because in the 3's times table we have 15. 24 also we have, and 36 as well. So we go with 3. 15 divided by 3 is 5, 24 divided by 3 is 8, and 36 divided by 3 is 12. No more common factors, so we have to stop here. So what do we have? 2 times 3. Again, 6. No matter which method, answer is same. Now here I just want to tell you that it's good to get comfortable with all the methods, practice all the methods, and be thorough with all the methods. But in case in your exams, they do not mention which method you have to use, be smart in picking up the method that will go really fast. Now look at 2 methods that we have here and the amount of work that each one has. This one went really fast, right? So if not mentioned, go for the fastest method. So that way you save your time and complete your paper well. And you have enough time for tough questions. But I know you won't find any questions tough if you are watching these videos and practicing it regularly. So, ready for the next one? We have to find least common multiple. Again, now instead of 2, we have 3 numbers. The method is not going to change. It remains the same. So, we write it here. 18, 24, and 42. The first method. Divide by 2 because all are even numbers. 18 divided by 2 is 9. 24 divided by 2 is 12. 42 divided by 2 is 21. Only one even number. So we will continue because it is least common multiple. We are not doing greatest common factor, right? If it was greatest common factor, we would have to go for the next number, next prime number. So we do 2, 9 as it is, 12 divided by 2 is 6, 21 as it is. Again, 2, 9, 3 and 21. We go with 3 now. 9 divided by 3 is 3, 3 divided by 3 is 1, 21 divided by 3 is 7. We still have 3, so we go with 3, 1, 1, 7, and the last one, 7, 1, 1, 1. So this is where we have to stop. So these are our numbers that we need to multiply. So it's 2 times 2 times 2 times 3 times 3 times 7. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, 24 times 3 is 72. And 72 times 7. Let's do that here. 72 times 7. That's 2 times 7 is 14. 1 carry. 7 times 7 is 49 plus 1, 50. So the answer is 504. Okay. So this is one of the methods. Let's go for the next method. Let's try another method so that you get practice of all the methods here. So we say 18, factorize it, 2 times 9, 2 as it is, and this becomes 3 and 3. Then we have 24. So that's 2 times 12, 2 as it is. This is 2 times 6. This 2 is down, this 2 comes down, and 6 is 2 times 3. Right? And 42. That's 2 times 21, 2 down, and 21 is 3 times 7. So we have done for all the numbers. Now let's write it down. 18 equals to 2 times 3 times 3. 24 equals to 2 times 2 times 2 times 3, right? I've just rearranged it. 42 equals to 2 times 3 times 7. So let's get the common ones first. So that's 2 and that's 3, right? Because each of these numbers are the multiples of 6. 6 times 3 is 18. 6 times 4 is 24. And 6 times 7 is 42. So we write the common factors here. 2 times 3. And we said 6 times 3, right? 6 is covered. This is 6. And then times 3 times 4, right? That's 2 times 3 is 4. So I'm writing directly. So because 6 times 4 is 24. And 6 times 7, this 7, is 42. So 2 times 3 is 6. 6 times 3 is 18. 18 times 4 is 72. And 72 times 7. We already did that here, right? So that's 504. And it's done. Good. I'm not going to use the method that we used to write the multiples like 18, 36, because it's going to be really tricky one here. Because it's like these are big numbers, right? So it's better to avoid that method in this case. When you have small numbers, that method is good. And the next one here is 14, 30, and 70. So 14, 30, and 70. All are even numbers. We will start with 2. 14 divided by 2 is 7. 30 divided by 2 is 15. 70 divided by 2 is 35. Now 15 goes in 3, right? So we'll do 3. 7 as it is, that's 5. And 35 as it is. Next prime number is 5. 7 as it is, 1, and that's 7. And then we say 7, 1, 1, 1. So what's the answer here now? We need to multiply this, right? So that's 2 times 3 times 5 times 7. So 2 times 3 is 6. 6 times 5 is 30, and 30 times 7. 3 times 7 is 21, right? So 30 times 7 is going to be 210. Simple. Let's do the next method. 14. So we say that's 2 times 7. That's it. Next is 30. So that's 2 times 15. That's 3 and 5. And this 2 comes down, right? So in the last 70 here, so that's 2 times 35. 2 comes down and 35 is 5 times 7. So that's it. Let's write it down. 14 equals to 2 times 7. 30 equals to 2 times 3 times 5. And 70 equals to 2 times 5 times 7. Right? So now we get the common factor. So that's 2. And then here we can do the 7 also, though there is no 7 here because we are doing least common multiple. And same thing here. We take 5 here, though 5 is not here because we are doing least common multiple. So we say this is 2 times 7 times 5 times 3. This 3 that is not covered, right? Rest everything is covered. So this becomes 2 times 7 is 14. 14 times 5 is 70. 70 times 3 is 210 because 7 times 3 is 21, right? So 70 times 3 is 210. We add 0 there. Okay? Good. Find the greatest common factor and the least common multiple of each set of numbers. So we are going to find both LCM and GCF over here. So I'm going to use now one method, not all the methods. And as I said, my favorite method is this: 16, 28, and 40 because that goes faster for me. So I'm going to do first GCF, greatest common factor. All are even numbers. Let me start with 2. So that's 8, and that's 14, and that's 20. Again, all are even numbers. So let's go for 2. That's 4, that's 7, and that's 10. No more common factors. So we stop here. So what do we have? 2 times 2, which is 4. So the greatest common factor is 4. Let's go for the LCM now. 16, 28, 40. That's going to be a longer one. That's 2. 16 divided by 2 is 8. 28 divided by 2 is 14. 40 divided by 2 is 20. Even numbers, 8 divided by 2 is 4. 14 divided by 2 is 7. 20 divided by 2 is 10. We still have even numbers, so 2. 4 divided by 2 is 2. 7 as it is. 10 divided by 2 is 5. We still have 2 here, so again by 2. That's 1, 7, and 5. Next is 5, 1, 7, 1. And last one is 7 here. So that's 1, 1, and 1. So we need to multiply all this, right? So that's 2 times 2 times 2 times 2 times 5 times 7, right? 1, 2, 3, 4 2's that we have. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 5 is 80, and 80 times 7. 8 times 7 is 56, right? So this is 80 times 7, there's extra 0. So that's 560. Ready for the next one? The same thing. So let's start first here with GCF. 54, 81, 135. Only one even number, so we are not going to use 2. Let's see if they are divisible by 3. 5 plus 4 is 9. Yes. 8 plus 1, 9. Yes. 1 plus 3 is 4. 4 plus 5 is 9. So yes, they all are divisible by 3. So we go with 3. 54 divided by 3 is 18. Times tables, you can do the rough work and check. 81 divided by 3 is 27. 135 divided by 3 is 45. 1 plus 8, 9, yes. 2 plus 7, 9, yes. 4 plus 5, 9, yes. So all are divisible by 3. 18 divided by 3 is 6. 27 divided by 3 is 9. 45 divided by 3 is 15. Again, all are divisible by 3 because they all are multiples of 3, right? So 3, that's 2, that's 3, and that's 5. Nothing common. So we end the process here. So that's 3 times 3 times 3 equals to 3 times 3 is 9, 9 times 3 is 27. So that's your GCF 27. Okay, let's do the LCM now. 54, 81, 135. So we'll start with 2 now because we're doing LCM, right? So that's 54 divided by 2 is 27. Rest remains as it is because they're not divisible by 2. Now we know 27, 81, and 135 are divisible by 3. So that's 27 divided by 3 is 9. 81 divided by 3 is 27. 135 divided by 3 is 45. Again, they all are multiples of 3. So we go with 3. That's 3, that's 9, and that's 15. All are multiples of 3. So that's 1, 3, and 5. Now we go with 3, right? 1 as it is, 1, and that's 5. Then we say 5, 1, 1, 1. These are the factors that we need to multiply to get our LCM. So we have 2 and then 3 how many times? 1, 2, 3, 4. 1, 2, 3, 4. I generally do this so that I don't make mistakes. And times 5. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. And now this is 15. Okay, so instead of doing 54 times 3 and then again times 5, I'm taking that as 15. And I can do my calculations here, right? So that's 54 times 15. That's 0, that's 4 and 5. 5 times 4 is 20. 2 carry, that's 5 times 5 is 25 plus 2, 27. That's 0, that's 11. 1 carry, that's 8. So the LCM is 810. And it's done. Okay, so we did both LCM and GCF, right? Least common multiple and the greatest common factor. Are you good with it? Are you confident? I'm sure you are. Here comes question 23. It says, Sarah has 2 ropes that she wants to use to tie butterfly knots. It's 2. To start, she wants to cut the 2 ropes into pieces of the same length. So she has 2 ropes that she wants to cut, and she wants to cut it into pieces such that the length of each piece is equal, right? Same length. And the 2 measurements are 84 inches and 116 inches. Part A. Find the greatest possible length of each piece so that no rope will be left unused. Greatest, right? So that tells us what we are supposed to do. Yes, we are supposed to do GCF, the greatest common factor. So let's do that. We have 84 and we have 116. So we will start with 2 because both are even numbers. So that's 2 there. So that's going to be 42. And that's 5 times 10, 1 here. So that's 16. So it becomes 8 now. Again, both are even numbers. So let's go with 2. So that's 21. That's twice. And then 1 there. So it's 18. 18 divided by 2 is 9. They do not have any more common factors. So we stop here. So what's the answer? So that's 2 times 2, which is 4. So the length of each cut piece should be 4 inches. She has to cut her 84 inches and 116 inches 2 ropes into tiny pieces, each one measuring 4 inches. Okay? And now we go to the next part. Write the sum of the 2 lengths and factor out the number you find in A. So basically, we have to write both the lengths as sum. So let's start doing that. 84 plus 116. And what does it say further? Factor out the number you found in A. You have to factor out this number. What do the numbers inside the parenthesis represent? Now 84 is what? 4 times this common factor. 4 times 21. And 116 is this common factor 4 and times 29. Right? If you want to check, you can check here. 21 times 4. That's 4 and that's 8. Again, 29 times 4. That's 36. 3 there. That's 8 plus 3, 11. Right? Now, the question says factor out the number you found in A. So we factor it out. So that's 4 and 4. So we take 4 out and we make brackets. And what is left from here? 21. 21 plus this 29 here. That's here too, okay? So that's what they're asking us to do. Then it says, what do the numbers inside the parenthesis represent? What do these numbers represent? It represents the number of pieces. Number of pieces. So this is from 84 inches, right? From that, each one is 4 inches and you can have 21 pieces over there. Same thing here, from 116, you can have 29 pieces, each measuring 4 inches. So the numbers inside represents the number of pieces that you can have with those two ropes, with those two measurements. So that's it. Good? Let's go to the next one. A florist combined 48 pink roses and 56 white lilies to make identical bouquet. Identical, which means all of them should be same, with no flowers left over, none are left. Find the greatest number of bouquets that the florist made. Greatest. So you know what to do. 48 and we say 56 here. We go with 2. So that's 24 and that's going to be 28. Right? 56 divided by 2. Again, both are even. We go with 2. So that's 12 and that's going to be 14. Again by 2. That's 6 and that's 7. No more common factors. So we say 2 times 2 times 2. Right? This part. That's 8. So 8 bouquet the florist can make. Find the number of pink roses and white lilies in each bouquet. How do we do this? We need to do this process there. Okay? So we write here 48 plus 56 equals to, what's common? 8. So we write 8 outside. 8 times 6 gives us 48. 8 times 7 gives us 56. So 48 represented roses and 56 represented lilies. So florist can make 8 bouquets with each bouquet having 6 roses and 7 lilies. It's done. Okay, so each bouquet will have 6 roses and 7 lilies. That's it. And it's done. And you get those numbers from here also. Like this numbers gives you that answer as well. Easy, right? Ready for the next one? A red light flashes every 14 minutes. A blue light flashes every 24 minutes. So that's blue and that's red. When will the two lights flash together again? If they last flashed together at 8 a.m. Now here, when we have this kind of questions, we have to find LCM. Okay, because when are they going to be together again? And together we have seen, like when we were listing the multiples, when was it first time they were having the common multiple, right? So when you have this kind of questions, it is always LCM. So let's find the LCM of these two numbers, 14 and 24. So we say 2, 14 divided by 2 is 7, 24 divided by 2 is 12, again by 2, 7 as it is, 12 divided by 2 is 6, again with 2, 7 as it is, that's 3, we go with 3, 7, 1 there, and finally we have 7 here. So this is what we need to multiply. So that's 2 times 2 times 2. 1, 2, 3, right? Times 3 times 7. And what is that? 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And 24 times 7. Let's do it here. 24 times 7. 4 times 7 is 28. 2 carry. 2 times 7 is 14. 14 plus 2 is 16. So the answer is 168. And that's going to be minutes because that's what they have given here, right? This minutes. Now, this is at 168 minutes they will flash together. But they're asking after how many minutes? No, they're asking us what time, when will the two lights flash together again if the last flashed together at 8 a.m. So now 8 a.m. and we have to add 168 minutes to it, right? So 168 minutes is what? It is 2 hours and 48 minutes, right? Because 2 hours is 120 minutes. So 168 minus 120, that's 8 and that's 4, right? So it's 2 hours and 48 minutes. So it's 8 o'clock, 8 a.m. This is 8 a.m. So plus 2 hours, it will make it 10 a.m., right? And plus 48 minutes, so 10:48 a.m. So that's the next time that they will flash together. Okay, so this is how you had to solve this question. Flash together again. So we did LCM and then we added that time. It was in minutes. So we converted into minutes and hours to add to the last time that they flashed. That was very important. If you had left it up to here, you've not completed your question. You're just saying that every 168 minutes they're going to flash together. But then after 8 a.m., when would they flash together is what they were asking. So this step was important to reach to your answer. And here comes the last question. Yay, and then we will be done. Find the product of 84 and 90. Okay, so it's easy multiplication, right? 84 times 9. I'm doing 9, not 90 now. 4 times 9 is 36. 3 carry. 8 times 9 is 72. 72 plus 3 is 75. So the product is going to be 756 and 0, right? Because it's 90, so we put 0 over there. So first part is already done. Find the product of the greatest common factor and the least common multiples of 84 and 90. So we need to find the product of LCM and GCF. So let's first find the LCM. So I'll do it here. 84 and 90. That's 2, that's 42, and that's 45. Again with 2, that's 21, and that's going to be 45 as it is. Now, 2 is not possible, so 2 plus 1 is 3, so we'll do with 3. That's 7, and that's 15. 15, so we do again with 3, 7 as it is, and that's 5. We do with 5, 7 as it is, 1 there, and finally with 7, 1 and 1, right? So LCM is going to be 1 and 2. So 2 times 2, 1 and 2, times 3, and then times 5 times 7. So that's 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. Now I'm not going to do times 5 and times 7. And 5 times 7 is 35. So I will do this calculations here like this. 36 times 35. Okay, so that way it goes faster and it's easier. Right? Otherwise you will do 36 times 5 over here and then again times 7. So you're doing double work. I don't want to do double work. Maths is all about being smart. So that's 0. 3 times 6 is 18. 1 here. 3 times 3 is 9 plus 1 is 10 plus 5 times 6 is 30. 0. So 3 carry. 5 times 3 is 15. 15 plus 3 is 18. So that's 0. 8, 8, 16. 1 carry. That's 2 and that's 1. So the LCM is 1260, right? Now let's find the GCF. So that's 84 and 90 here, and we go this. Both are even, so we start with 2. That's going to be 42, and that's 45. Now both are not even, so 2 is not possible. Let's go for 3. 4 plus 2 is 6. Yes. 4 plus 5 is 9. So divisible by 3. So that's 14, and that's going to be 15. No more common factors. So our GCF is 2 times 3, which is 6. Right? So we have LCM and we have GCF. Now it says find the product. So we have to multiply that. So let's do the multiplications here now. 126 times 6. I'm not going to do 60 there. As we did here, we'll just add 0 later, right? So 6 times 6 is 36. 3 carry. 6 times 2 is 12. 12 plus 3 is 15. 1 carry. 6 times 1 is 6 plus 1 is 7. So we say LCM times GCF equals to 1260 times 6, which is equals to, so we say this 756, and we have to have this extra 0, right? So that's the answer. So this is the second part. Let's see the third part. What do you observe about your answers to parts A and B? So let's check our answers to part A and B. So the answer for part A is 7560, and the answer to part B is also 7560. So what do you observe? We observe that the product of two numbers, right? We say product of two numbers, whatever those numbers are, equals to product of their LCM and GCF, right? Here in this case, it was 7560, this. And here in this was also 7560, right? So the product of two numbers is equal to the product of their LCM and GCF. So that's what we observe over here, right? Let's go to part D, and then with that we'll be done. It says, choose two other numbers and repeat parts A and B. So we have to find the product, we have to find LCM, we have to find GCF, and multiply GCF and LCM. Do you get the same results? Okay, so let's check. What two numbers should we take? Let's take numbers as any two numbers, right? So we say 48 and 56, two numbers. So let's multiply and get their product first. So 48 times 56. So 0. 5 times 8 is 40. 0 here, 4 carry. 5 times 4 is 20 plus 4, that's 24, plus 6 times 8 is 48. 4 carry. 6 times 4 is 24. 24 plus 4 is 28. So that's 8, 8, 6, and 2. So the product of these two numbers is 2688. Now let's find the LCM of these two numbers, 48 and 56. 2. 48 divided by 2 is 24. 56 divided by 2 is 28. Again we go with 2. 24 divided by 2 is 12. 28 divided by 2 is 14. Again with 2. 12 divided by 2 is 6. 14 divided by 2 is 7. Again with 2. 6 divided by 2 is 3. And 7 comes down as it is. Now we do 3. That's 1. 7 as it is. And finally 7 is here. So the LCM of this number is LCM equals to 1, 2, 3, 4. 1, 2, 3, and 4 times 3 and times 7. So that's 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is 48. And 48 times 7. Let's do the calculations here. 48 times 7. 8 times 7 is 56. 5. 7 times 4 is 28. 28 plus 5 is 33. So the LCM is 336. Okay. Next we need to find is GCF, right? So we say 48 and 56. 2. So that's 24 and 28. I can copy from this table right here. That's 2, 12, 14. That's 2, 6, and 7. Right? Same stage here. So these are the factors for GCF now. So GCF equals to 2 times 2 times 2. So that's 2 times 2 is 4. 4 times 2 is 8. Right? What was the next step? We have to find the product of LCM and GCF. So LCM times GCF we have to do, right? So we have to do 336 times 8. 336 times 8. 6 times 8 is 48. 4 carry. 8 times 3 is 24. 24 plus 4 is 28. 2 carry. 8 times 3 is 24. 24 plus 2 is 26. So that's 2688. Same answer. Okay. So yes, we can conclude that product of two numbers is equal to the product of their LCM and GCF. Right? That's because, now understand the logic here. What's happening? When you take the LCM, you do not take the common factors twice. You take them once, right? And GCF has the common factors. So in this case, look here, when we had 2, 2, 2, they both were dividing, right? This 2, 2, 2 were applicable to both the numbers. And that's why we took it only once. Okay? And the same numbers are here. So we took it once and again we are taken from GCF. So that's now it became twice, right? So that's why you get that answer. Understood the logic? So no matter which numbers you take, it will always remain true. Okay? So with this, we end the chapter and we are done. How did it go for you? Are you confident? Yes? That's great. See you in the next video. Until then, keep practicing. Goodbye.